On this one, we are going to find the tangent line, the equation of the tangent line that is tangent to this equation at this point. So to write the equation of a line, I would personally use point slope, because for point slope, all I need is a point, which I have. This is technically a point on this equation, but it's also going to be a point on the tangent line, so it kind of doubles. Just plug in 1 for x1 and 9/4 for y1. So all I really need here is the slope. So the slope of the tangent line will be the derivative of this function at a x value of 1. So if I can figure that out, I can plug it in, and there will be my equation. All right, so to take the derivative of this, I've got 4 times, let's see, x times y. Well, x times y implies that I need the product rule. So product rule, take the derivative of the first times the second plus the derivative of the second, which would be 1 dy dx times the first. So in the first half of the product rule, I'm taking the derivative of x with respect to x. So in that case, the x is the variable and y is like the constant. And then the second part of the product rule, I'm taking the derivative of y with respect to x. So now it's like y is the variable and x is the constant. Okay, so that's where that comes from. And then, of course, the derivative of a constant is just 0. So now I can solve this for dy dx. Divide both sides by 4. And I can go ahead and plug in my point here. When x is 1, y is 9/4. So it looks like I would need to subtract that over. And the derivative for an x value of 1 would be negative 9/4. So that's going to be the slope of that line at that point. So negative 9/4. So negative 9/4. And this guy should be my answer here.